Okay, this is a short little video where I do a basic introduction of hyperbolic functions. In this course, I'm going to basically kind of show you the derivatives of hyperbolic functions and to show you what they look like and kind of what they're used for. But that's basically it. I don't go into any more detail in this course, so I want to give you a little introduction. So let's look at what is a hyperbolic function, okay? Well, hyperbolic functions are formed by taking combinations of two exponential functions, e to the x and e to the negative x. The hyperbolic functions simplify many mathematical expressions and occur frequently in mathematical applications. Where I've seen the most of this is in engineering. But there's many other places. I'm just familiar with the engineering part, but this is used a lot. That's an N, guys, okay? So, the definitions and identities. This you won't need to know, but I just kind of want to show you how you say everything. The hyperbolic sine function and the hyperbolic cosine functions are defined by these following equations. You have hyperbolic sine is e to the x minus e to the negative x over 2. Hyperbolic cosine is e to the x plus e to the negative x over 2. And we often read the notation of hyperbolic sine x as sinh x. So you'll hear me call that sinh, rhyming with pinch. And hyperbolic cosine x, see how the h is after that? Okay, that's how they is cosh x, rhyming with gosh. So the difference between this and regular trig functions is the h at the end, okay? From this basic pair, we can then define the hyperbolic tangent, cotangent, secant, and cosecant functions. We see that the hyperbolic functions bear many similarities to the trigonometric functions after which they are named. So here's our 6 hyperbolic functions, just so that you'll look at them. So here's hyperbolic sine right here. Hyperbolic cosine. Now this is the one I'm most familiar with because they call this a catenary, but if you see how this looks, it looks like a hanging wire between two telephone poles. And so with engineering, they look at, it's basically a hyperbolic cosine function. Now remember, we can call this sinh x and cosh x too, all right? Here's hyperbolic cotan and tan, all right? And this is the actual definition down here, but I just wanted to show you what they look like here. Then you have hyperbolic secant is how this looks here, and y equals sech x, and hyperbolic cosecant. All right. The other thing you need to know that hyperbolic tangent is hyperbolic sine of x over hyperbolic cosine, and the same with hyperbolic cotan is hyperbolic cosine over hyperbolic sine. Okay? I'm going to say hyperbolic a lot. I apologize. All right, so let's go along here and look at some of the identities. They're going to look kind of familiar, but a little bit different. This I'm not testing you on. These are basically just for your notes, so that if you ever go on in math, you'll know that you have this in one spot, that here's your identity for your hyperbolic functions. All right? And here is the part that I want you to memorize, and actually if you want to make a derivative card over it, is our hyperbolic functions derivatives. So here we go. Let's look at the derivatives here. I think I can get mostly on the screen here. Is hyperbolic sine of u is cosh u du dx. So this is going to be the same as what we've done before. I want you to make a derivative card where this is my function right here on this side. And this is the derivative on this side. And don't forget the chain rule. Okay? So this actually on this side, just to show you, this is going to be y prime is going to be hyperbolic cosine of u times u prime. And continue on. So this is hyperbolic cosine is hyperbolic sine of u times u prime, etc., etc. Now if you'll notice, these look very similar except some of the signs are different. So hyperbolic tan is hyperbolic secant squared u times u prime. Hyperbolic cotan is the derivative is negative hyperbolic cosecant squared u, I forget the negative, times u prime. So far, this one is the only negative one so far. I just want you to notice that everything else is positive. And it looks kind of familiar. This one is also negative. hyperbolic secant is negative hyperbolic secant of u times hyperbolic tangent of u times u prime. This one's negative. So it's like the top three are positive and the bottom three are negative. And the last one would be y prime is negative hyperbolic cosecant u times hyperbolic cotan u times u prime. Okay, so here's the derivatives. Now you will be tested on it this course. They'll be part of the derivatives that I'll have you do at the end of the year. So this is very important that you memorize these. So these you have to memorize. Okay? So let's look at this. Now this is strictly also for your notes, so please don't freak out. Notice I have it here just for your notes. Here's the derivative of the inverse hyperbolic functions. We will not be using them in this course, but I want you to have them in your notes. Okay, so here you go for that. All right. And the last thing is on the bottom of this page, if I can make this page move because it's actually froze up right now, is we're going to do some derivatives. So let me see if I can get this page to move down. There we go. All right. So let's just do a few and you'll see how similar they are. So make sure you have your derivatives open. Now I have, whoops, sorry about that. Come back. Doesn't want to go down there, does it? Wow, it's freaking out, isn't it? I wonder if it's because it's after school and it doesn't want to be doing this either. Well, I guess we'll do the examples in class because, oh, let me see, maybe it might let me work now. Hang on a second. Okay, let's try this one more time. I'm sorry about that. All right, so let's do these 4 problems. So if you'll see here, I have hyperbolic sine squared 3x, so we're going to write it like this so that you will recognize that it's squared like this, so that our outside function here is going to be the power rule. So it's going to be 2 times sinh of 3x to the first, okay, don't touch it, times the derivative of the inside, which is going to be hyperbolic cosine, or cosh 3x times 3. So this is very similar. So you have y prime equals 6 sinh 3x cosh 3x. Alright, so there is the first one. Number 2, I've got y equals 7 hyperbolic sine of x over 4. Again, you guys could probably do this without looking because we've done this before. This is 1/4 of an x. So I'm going to do 7 times the hyperbolic sine, or sinh, of x over 4. Excuse me. The derivative of sinh is cosh. Didn't mean to do that. So this is going to be 7 cosh of x over 4 times the derivative of the inside, which is 1/4. So y prime is going to be 7/4 cosh x over 4. Again, not very difficult. You just need to know the derivative. So basically part of this is just memorizing. The bottom 2 are a little bit more in depth. I'm going to do the one on the right first because it's just a little bit shorter. So I have y is the natural log of cosh x. So y prime, natural log, is 1 over cosh x times the derivative of cosh, which is sinh x, which is sinh over cosh x, which definitely is, you guessed it, hyperbolic tan of x. So there's this one. Alright, so that one's a quickie. Now let's do this one on the left. It's got some radicals and everything in it. So we've got this multiplied by this, so this is our f and our g's. So f is 3 radical x. F prime is going to be, because that's x to the half, 3 halves x to the negative 1/2. Okay? G is going to be hyperbolic tangent of radical x. G prime is going to be hyperbolic secant squared of that times, and then I have to do the derivative of radical x, which is 1/2 x to the negative 1/2. So when I go to do this, I have y prime equals f prime g 3 halves x to the negative 1/2 this is hyperbolic tan, I forgot the H there, sorry, hyperbolic tan of radical x, okay, plus fg prime, 3 radical x, times, put this in bracket, I'll put this in front, 1/2 x to the negative 1/2 hyperbolic secant squared radical x. Now, there's a couple ways to do this, because I know if I multiplied this through here in this term, because this is x to the half times x to the negative half, that would actually cancel each other out. But the other way I like of this is that here's a term here and here's a term here. I'm going to actually try to factor it the way it is. And if you'll see, this is actually something I can factor out because I have a 3 times this here, if you'll see it, because it's all multiplication. So I can actually factor out a 3/2 x to the negative 1/2. And when I do that, I end up with, okay, hyperbolic tan of radical x plus radical x hyperbolic secant squared radical x. And that will be our answer, or our factored form for this one. Okay. So there's a little introduction to show you how easy the derivatives are. I'm going to have you work in the book and practice just a few, but like I said, this is not a huge topic in this course, but I do need to introduce it to you and have it for your notes.